In this problem, we need to find out the slope of the tangent and the normal at the indicated point, that is at theta equals to negative pi over 2. And we have the coordinates x and y, which will be any point on the curve given by as shown on screen. So let's begin. So here, in order to find out the tangent, first we'll have to take a look at the equation of the curve, which is given in a parametric form. So we'll take x equals to a times theta minus sine theta, and we are going to take its derivative on both sides with respect to theta. So that will be, so here a is a constant, so we have a multiplied to derivative of theta is 1 and derivative of sine theta is cosine theta. Right. Then we have the y, which is given by a times 1 plus cosine of theta. So here also we'll take the derivative on both sides with respect to theta to get a times. So we have 1, which is a constant, so derivative of cosine theta will be negative sine theta. Now what we'll do, in order to find out dy over dx, we will take dy over d theta and divide it with derivative of x with respect to theta. So that will be equals to a times negative sine theta divided by a times 1 minus cosine theta. Here a and a will get cancelled, and this is also equivalent to sine theta divided by cosine of theta minus 1. The next task will be to find out the slope of the tangent at theta equals to negative pi over 2. So let's begin. So our slope of our tangent will be given by the derivative of y with respect to x calculated at theta equals to negative pi over 2. So that means we will replace the value of theta with negative pi over 2 into our slope. So we have sine of negative pi over 2, and in the denominator we have cosine of negative pi over 2 minus 1. So sine of negative pi over 2, so that's negative sine of pi over 2 divided by cosine of negative pi over 2, so that's simply cosine of pi over 2 minus 1. We have sine of pi over 2, that is 1, so we have negative 1 in the numerator, and cosine of pi over 2, so that's 0, so we have negative 1 in the denominator. Both cancels out to give us 1. So that means the slope of the tangent at calculated at theta equals to negative pi over 2, so that is 1. Now we'll calculate the slope of the normal at that indicated point. So the slope of the normal will be the negative reciprocal of the slope of the tangent calculated at theta equals to negative pi over 2. So that means this will be, we have negative 1 in the numerator divided by the denominator, which is the slope of the tangent. We have already calculated it to be 1. So that means our slope of the normal is negative 1.